Okay, Algebra 1, we are doing the section converting to slope-intercept form. So slope-intercept form is a very useful way to write an equation, and it will look like this. Y equals mx plus b. Might look familiar because we used this equation when we were working with arithmetic sequences. Today, m is going to be your slope, and we considered that our common difference before. That's kind of like our rate of change. And b is the y-intercept. So it's where it crosses the y-axis. So that's a couple little things that we're going to talk about. This equation is going to be very useful to you. So it says, consider the graph at the right. Which of the following points are on this line? So we're going to just use these points. 2, 0. So go over 2 and 0. And we can say yes. -1, -1, 0. No. 6, 2. So go over 6 and up 2. It's hard to tell. Probably. -3, -3. So -3, -3 right here. No. 5, +5, and 1.5. That looks right. And then 8, 3. So now all of a sudden I'm given coordinates that are off my grid. And whereas I could try to guess, I might not be accurate, I might. So we don't know. Okay? So it says even though points 6, 2 and 8, 3 aren't pictured, we can still be confident that they're on the line. Pretty confident, yep. Just because it looks like there. But here is the real goal for the lesson. And that is to be able to tell you if 128/63 is on the line above. To answer this, we need to get more comfortable with linear equations. And we did this a little bit in the previous lesson. Let's start by graphing one with a table. So I have this equation right here, and I'm going to graph it. We've practiced this before. So y equals -2 times -1 plus 3. Y equals -2 times 0 plus 3. Y equals -2 times 1 plus 3. And y equals -2 times 2 plus 3. Then I can go through, and a negative times a negative gives us a positive. So this is going to be 2 plus 3. So this is y equals 5. Anything times 0 is 0. 0 plus 3 is 3. -2 times 1 is -2 plus 3, which gives us 1. And -2 times 2 is a -4 plus 3. So that's going to give us a -1. So our ordered pairs, when I put in -1, I get 5. When I put in 0, I get 3. When I put in 1, I get 1. And when I put in 2, I get -1. So it says graphing linear equations with tables takes way too long. So I can graph this by what we've been practicing. -1, +5, 0, 3, 1, 1, and 2, -1. So there we are able to graph a line. Okay, but it says graphing with linear equations takes way too long. What we notice about this equation is that its slope is, well, if you were just going to look at this and go down 2 over 1, down 2 over 1, our slope is -2, and it crosses the y-axis at 3. Okay, so now when we can make these connections, we can graph much more quickly. So, like I said before, our slope-intercept form is y equals mx plus b. M is the slope, and we used that in our equation before. And b is the y-intercept. just reaffirming how important this equation is, okay? So now we're going to do some practice. So the first thing is, before we start graphing, let's just start recognizing and picking out the slope and the y-intercept. So in the first one, our slope is 3. Our y-intercept is a positive 4. I'm just going to rewrite our equation up here. Our slope on the second one is negative 2/3. Our y-intercept. Now, because this is a plus, if there is a minus here, that means our y-intercept is a negative 5. Our next one, our slope is, if there's nothing in front of the x, there's a 1 there. And our y-intercept is positive 6. Now this one is tricky. There's nothing in front of the x, so we are going to assume there's a 1, so our slope is a negative 1. And if there's no y-intercept, what do you think is there? Where would it cross the axis that would make sense that nothing is written there? Think about that for a second. 0. Okay, we could write 0 here, but it wouldn't change the equation. So we just know that if it doesn't have a b, then our y-intercept is 0. So in order to graph this, we can have 3 steps. Plot the y-intercept. That's where you're going to start. So on this one, my y-intercept is negative 1, so that's where I start. Put a dot there. Use the slope to plot more points. So my slope is a positive 3. Remember, if it's a whole number, just put it over 1. So now I'm going to go up 3, 1, 2, 3, over 1. Up 2, 3, 1, 2, 3, over 1. And then we can use a straight edge. We want a nice straight line. I want you guys to observe that, notice this point that we didn't graph down here. We could go from this point, we could go down 3 and left negative 1, because negative 3 over negative 1 turns into a positive 3. So that's something to kind of keep in mind there, that sometimes you can go to the opposite too, especially if you're running out of room on your graph. That happens. So let's quickly review slope, and then we'll graph some more equations. 4/5 means up 4, right 5. 6 means up 6, right 1, because remember 6 over 1. Oh, they put it right there. Negative 3 means down 3, right 1. Negative 2/3. Now, I will always take the negative with the top number if I can, so down 2, right positive 3. But to be fair, you could also go up 3, left, or sorry, up 2, left 3. Just so you guys know, you might notice that later on. Oops. Okay, so now we are going to do some graphing. So the first problem, I start at positive 1. Remember, if it's a whole number, put it over 1. Up 2 over 1, up 2 over 1. Draw your line. Next one, I start at negative 3. 1, 2, 3. And then my slope is up 1 over 2, up 1 over 2. My third one, start at positive 2. Remember, if it's a whole number, just put it over 1. So now I'm going to go down 5. 1, 2, 3, 4, 5 over 1. There was only really room to put 1 dot on there. But you really only need 2 points to make a line. Next one, I start at negative 2. And this one, I'm going to go down 3. 1, 2, 3 over 4. 1, 2, 3, 4. But I'm going to show you that I could go up 3. 1, 2, 3, as long as I did negative 4 left. 1, 2, 3, 4. And you can see that these are still going to be in line with each other. Okay. Why don't you guys pause my video and try to do the next 4 on your own and then double check with my answers. So pause the video, do the next 4. Remember, if there's nothing here, it's 0. Up 3, 1, 2, 3 over 2. Positive 3. Now this one I can't go up 1, 2, 3, 4, so I'm going to go down 1, 2, 3, 4, but I have to go to the left because it has to balance each other out. It has to be negative. Remember, -4, -1 equals +4. Just like above, there's nothing there. There's a 1 plus a 0, so we start here. Up 1 over 1. And then this one, we have a -4. 1, 2, 3, 4. And I can't go down, so I'm going to go up 4. 1, 2, 3, 4. But I'm going to make sure I go my negative is my 3. 1, 2, 3. So anytime you have a negative, one of the ways has to be negative. So you either have to go down negative or left negative. So just kind of keep that in mind. So on this one, I put my negative, my 4 was positive. I went up 4, left -3. Okay? Okay, so the last type of problems are to look at the graph and be able to write its equation. So in order to write the equation, we need the slope and the y-intercept. So our equation is going to read y equals our slope. Find 2 points, just like we've done before. Up 1 over 3. So 1/3 x plus, and where does it cross? +2. This one, let's find some points. This one I would go down 2, right 1, 2, 3. So y equals -2/3 x. And then it crosses at -1. So I'm going to write -1. You could also write plus a -1 if you wanted. Crosses here. Looks like it crosses there. So I'd go up 1, 2, 3, 4, 5. Up 5 over 1. So y equals 5 over 1x. And then it's at a -2. Or y equals 5x minus 2. Okay, a couple more here. Our intercept is at +4. Looks like it's going down by a -1, so down 1, right 1. So y equals -1x plus 4. This one, my y-intercept 0. Down 2, right 1. Y equals -2x plus 0. Y equals -2x could be the final way to write that. Last one here. My y-intercept is -3. Looks like it's a slope of a 1 over 1, which is a +1. Y equals 1x minus 1, 2, 3 is where it crosses. And you guys also might see this y equals x minus 3, either one. Okay, so now let's take a look at the original problem. They give us an equation, or they give us a line, and they want to know, is this on the line? So what could we do? What do we now know that we could see if this is on the line? I want you guys to think about that for a second. And I think that we are going to save this question and we are going to talk about it in class.